Question number 121. Identify the correct statement with respect to the fermentation. First option, it's a metabolic process in which oxidation of substrate occurs without any external electron acceptor. Second, it's a reaction occurs in the cytoplasm of aerobic bacteria and in mitochondria of eukaryotes. Third, it involves the synthesis of one molecule of ATP and NADH. Fourth, it involves complete oxidation of pyruvate. Fermentation can be alcoholic fermentation or it can be lactic acid fermentation. See, fourth option, it involves complete oxidation of pyruvate. No, complete oxidation of pyruvate takes place in aerobic respiration, not in the fermentation. Third, it involves the synthesis of one molecule of ATP and NADH. No, there is no ATP production during fermentation, whether it is alcoholic or lactic acid. Second, it is a reaction occurs in the cytoplasm of aerobic bacteria and in mitochondria of eukaryotes. No, in mitochondria of eukaryotes there is no fermentation. Fermentation takes place in the cytoplasm of anaerobic bacteria or the bacteria which have fermentation. So this option is also ruled out. First option, it's a metabolic process in which oxidation of substrate occurs without any external electron acceptor. This is true. There is no external electron acceptor in case of fermentation. NAD plus is the electron acceptor. So the correct option for the given question is option number 1. Let's move on to the next question. Question number 122. Match the column 1 with the column 2 and select the correct option. A. Terminal electron acceptor of mitochondrial ETS, magnesium. B. Pyruvic acid decarboxylase, second synthesis of chlorophyll. C. Succinyl coenzyme A, third zinc. D. Lactic acid dehydrogenase, fourth oxygen. See here, you have to match the items of column 1 to the items of column 2. The terminal electron acceptor of mitochondrial electron transport system or electron transport chain is oxygen, as it is the step of aerobic respiration. So A goes with fourth, hence option number 1 and 3 are ruled out. Now B, pyruvic acid decarboxylase has a cofactor which is magnesium. So B goes with first, hence this option is also ruled out. C, third, succinyl coenzyme A is an intermediate during the Krebs cycle and it is the precursor of chlorophyll. So C matches with second. And the fourth is lactic acid dehydrogenase. So the cofactor for the lactic acid dehydrogenase is the zinc. So D matches with the third. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 123. In aerobic respiration, net ATP produced from one glucose molecule through ATS only in human kidney cells are first option 38, second 36, third 34, fourth 32. In aerobic respiration, the net ATP production from one glucose molecule through ATS only and in human kidney cells. So there are many clauses. What is the ATP production in the human kidney cells during the aerobic respiration from one glucose molecule? See, the net ATP production in human kidney cells during the aerobic respiration is 38. But in the question it is asked through ETS only. So through ETS the ATP production takes place by NADH2 and FADH2. We cannot consider the substrate level phosphorylation. So from one glucose molecules, 2 ATP molecules are synthesized directly in glycolysis and 2 ATP molecules are synthesized directly in Krebs cycle. So in glycolysis, the net ATP synthesis is 2 ATP, which is substrate level phosphorylation, and in Krebs cycle also there is 2 JTP molecule synthesis, which is substrate level phosphorylation. So in the question, it is asked through ATS, so we cannot consider these 4 ATP molecules which are synthesized directly. So you have to minus these 4 ATP molecules from these 38. So 38 minus 4, that is 34. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 124. Arrange the following respiratory substrates in the descending order of their RQ values. A. Glucose. B. Oxalic acid. C. Albumin. D. Palmitic acid. See here, you have given some respiratory substrates and you have to arrange them in their descending order of the RQ, respiratory quotient. You have to remember that the RQ for carbohydrates is 1. So find out, is there any carbohydrate? Yes, C6H12O6, it's a glucose, it's a carbohydrate, and the RQ of carbohydrate is 1. Albumin is a protein. For proteins, the RQ value is 0.9. For albumin, it will be 0.9. Oxalic acid is an organic acid, and for organic acids, the RQ value is more than 1. And for oxalic acid, it is 4. Palmitic acid is a fat, and for fat, the RQ value is 0.7. So the maximum RQ value is of B, that is oxalic acid, followed by A, that is a carbohydrate, then C, which is a protein, and then D, which is a fat. So the correct option for the given question is option number 1. Let's move on to the next question. Question number 125. A is a metabolite which is common product formed during respiratory breakdown of fats, proteins and carbohydrates. It is also involved in the biosynthesis of B. Select the option which correctly fills A and B. See, this question says that there is a common metabolite between the breakdown of fats, proteins and carbohydrates, and it is acetyl coenzyme A. So A is acetyl coenzyme A, hence all the options are ruled out except the fourth one. And B, this acetyl coenzyme A is involved in the biosynthesis of. So it is involved in the biosynthesis of carotenoids. So the correct option for the given question is option number 4. Let's move on to the next question.